Hi. So in this video, we will derive the equation for centroid of a triangle. Centroid of a triangle. Okay. So for that, I considered a triangle. Let me call the triangle as triangle ABC. Triangle ABC of width of base width B of base width B and height height H. Okay. So consider a triangle ABC of base width B and height H as shown in figure. Now, if you take a triangle, if you take the triangle, if G is the centroid of the triangle, if I draw centroidal axis, means if I draw reference axis, let me draw the reference axis here, reference axis here, reference axis X and reference axis Y. Okay. Now let me draw the centroidal axis now. Centroidal axis. Centroidal axis is usually denoted by capital X and capital Y. Capital Y. Now you can see the triangle is symmetric about Y axis. The triangle is symmetric about Y axis. See, if the figure is symmetric about Y axis, then the X bar is known. Means the distance of the centroid from the reference Y axis is known. X bar is equal to say total base width of the triangle is B, then half of the base width means B by 2. Okay, the figure is symmetric about Y axis. Y axis is dividing the figure into two equal parts. Therefore, as the figure is symmetric about Y axis, X bar is known, that is B by 2. Okay. Now for the triangle, we got the equation for X bar. X bar is equal to what? B by 2. But if you see the symmetry about the x-axis, okay, if you check symmetry about x-axis, you can see that the figure is not symmetric about x-axis. Therefore, we have to derive the equation for y bar. We have to derive the equation for y bar. So below, we will write a sentence as the figure is symmetric about y-axis, as the figure is symmetric about y-axis, the x bar is equal to, therefore x bar is equal to directly b by 2. Now we have to derive the equation for y bar. Okay, to derive the equation for y bar, consider an elemental strip, consider an elemental strip of thickness dy at a distance y from, at a perpendicular distance y from base of the triangle, at a perpendicular distance y from the base of the triangle. Okay, let me call these 2 points as point E and point F. Okay, so what will be the remaining distance here? Remaining distance will be h minus y. Okay, remaining distance will be h minus y. Okay, h minus y. And here one more thing, whatever the thickness of the elemental strip we have considered, that dy, it is assumed to have very negligible thickness. Okay, it is assumed to have very negligible thickness, so we will not take into consideration of this dy while finding this height h minus y. Okay, so directly you can write y and remaining distance as overall height minus y h minus y. Okay, now from the figure you can see that triangle AEF and triangle ABC are similar triangles, right? From figure, from figure, triangle AEF and triangle ABC, triangle AEF and triangle ABC are similar triangles. Okay, similar triangles. Now we will apply the property of the similarity rule. Okay, let me take B1 as width of elemental strip. Okay, let me take B1 as width of elemental strip. Now we will apply the similarity rule. Width of smaller triangle AEF B1 divided by width of larger triangle B is equal to height of smaller triangle is h minus y, h minus y, height of larger triangle is h. Therefore, b1 by b is equal to, I will split this h minus y by h. Therefore, b1 by b is equal to 1 minus y by h. Therefore, b1 is equal to b into 1 minus y by h. b1 is equal to b into 1 minus y by h. So, this is the first step. Okay. What is the first step? We have to take the similar triangles AEF and ABC, apply the property of the similarity rule, and obtain the expression for, obtain the equation for B1 in terms of B. Okay, this is the first step. Okay, second step, area of elemental strip is equal to, let me call the area of the elemental strip as dA. Okay, let me call area of the elemental strip as dA. dA is equal to, so it is a rectangle. So here we have some slope. Okay, as I said before, whatever the thickness of the elemental strip considered here, it is assumed to have very negligible thickness. So these slopes are neglected and it is almost considered as a rectangle of sides B1 and dy. Okay, that elemental strip is considered as a rectangle of sides B1 and the dy. Therefore, dA is equal to B1 into dy. B1 into dy. Therefore, dA is equal to, what is B1? B1 is B into 1 minus y by h, substitute B into 1 minus y by h into dy. So this is the second step. Now area of triangle is equal to, let me call it as A. A is equal to, we all know the formula for area of the triangle. It is half into base into height. Half into base into height. Okay. So this is the third step. Okay. First apply the similarity rule. Secondly, you find area of the elemental strip. Then write the formula for area of the triangle. Okay. Now we are interested to obtain the expression for y bar. We are interested to derive the equation for y bar means distance of the centroid from the reference x-axis. Okay, so we have a generalized formula to find the centroid. Okay, that is y bar is equal to you need to remember this formula. It is a simple formula: moment of area divided by total area. Okay, moment of area divided by total area. Okay, now total area is known, that is half into base into height. Okay, area of the full triangle, but we don't know moment of area. We will find it now. To find moment of area, initially we will find moment of elementary strip about the base. Okay, moment of elemental strip about base is equal to, so what is moment of force? Moment of force is force into perpendicular distance. Similarly, moment of an area is area into perpendicular distance. Now we want moment of elemental strip about the base. Moment of elemental strip about the base. Therefore, it is area of elemental strip into perpendicular distance y. We are taking moment about the base of the triangle. So dA into y. Area of the elemental strip is dA. Perpendicular distance of the elemental strip from the base is y. Therefore, it is dA into y. dA into y. Okay. Now we got moment of elemental strip about the base. Therefore, moment of whole area is equal to. Therefore, moment of whole area about base is equal to. Now you got the moment of elemental strip about the base. To get moment of whole area, you have to integrate the moment of elemental strip about the base with limits from 0 to h. Okay, with limits from 0 to h. Okay, by this we'll get moment of whole area. Okay, we want moment of area now. It is nothing but moment of whole area. Okay, therefore integration from 0 to h. So you know the equation for dA, that is b into 1 minus y by h into dy. Substitute here. d is equal to b into 1 minus y by h. b into 1 minus y by h into dy into y. Okay, then integration from 0 to h, b into, you take this y into the bracket, so it becomes y minus y square by h into dy. Therefore integration, so b is constant, take it outside the integration. Integration of y is y square by 2 minus integration of y square is y cube by 3 h. You keep as it is. Limits from 0 to h. Now you can apply the limits. B into h square by 2 minus h cube by 3h. Okay, I have applied the limits now. Lower limit is 0, so there won't be any further equation. So b into see this h cube, in the h cube, so here in the new denominator we have h, so this h cube becomes h square if you cancel. Therefore it is h square by 2 minus h square by 3. Okay. Further you simplify this, b into LCM is 6. Therefore here 3h square minus 3 into 3 2 is 6. It will be 2h square. Finally 3h square minus 2h square is h square. Therefore it is bh square by 6. Now you got moment of whole area about the base. You got moment of whole area about the base, that is bh square by 6. You know the formula for total area, that is half into base into height. Okay. Therefore y bar is equal to moment of area is bh square by 6 divided by total area half into base into height. Okay. Therefore y bar is equal to bh square by 6 into 2 by bh. Here 2 ones are 2 3 is 6. B and h gets cancelled. B and 1h gets cancelled. Okay. So the remaining equation is y bar is equal to h by 3. Y bar is equal to h by 3. So this is the equation for the y bar. Okay. Equation for y bar. To this we have derived the equation for y bar. Therefore, finally, for a triangle, for a triangle x bar is equal to x bar is equal to x bar is equal to b by 2. X bar is equal to b by 2. So here we have written it, distance of centroid from reference y axis, and y bar is equal to h by 3. Okay. Y bar is equal to h by 3 from the base, and it is 2h by 3 from the apex. Means apex means this point. 2h by 3 from the apex means overall height of the triangle is h, no? Overall height of the triangle is h. So if you do h minus h by 3, you will get 3h minus h by 3, you will get 2h by 3 from the apex. Okay. So for a triangle, the distance of centroid from its base is h by 3, and distance of centroid from the apex is 2h by 3. Okay. And x bar formula is b by 2. Okay. X bar formula is b by 2. Even from this side also it is b by 2 only. Okay. If you measure the centroidal distance from other end. Okay. So this completes the derivation. So I will repeat the steps very in brief. So initially you have to take a triangle ABC of base width b and height h. So I have considered an elemental strip of width b1, thickness dy at a distance y from base of the triangle. Okay. So as the figure is symmetric about y axis, x bar is known. X bar is equal to b by 2, that I have written here. X bar is equal to b by 2. And so initially you have to take the similar triangles AEF and ABC, apply the property of the similarity rule, and obtain the expression for B1 in terms of B. Okay, this is the first step. Second step is to find the area of the elemental strip. dA is equal to B1 into dy. Okay, B1 formula, it is known, B into 1 minus y by h. Substitute here in this equation. Then you write the equation for total area, that is area of the triangle, half into base into height. Okay. So this is the third step. Then next step, we are interested to find the expression for y bar. So we have a generalized formula, y bar is equal to moment of area divided by total area. Okay. Total area is known, that is half into base into height. But we want moment of area. To find moment of area, what we have to do? we have to find moment of elemental strip about the base. That is, moment of area is equal to area into perpendicular distance. Area of the elemental strip is dA, perpendicular distance is y, so it becomes dA into y. Okay, so to this we got moment of elemental strip about the base, but we want moment of the whole area. For that we have to integrate from limit 0 to h. Okay, 0 to h, the same equation, and substitute the equation for dA, that is b into 1 minus y by h into dy, and do the integration and apply the limits and simplify. Finally you will get the simplified equation as bh square by 6. Now to this we got moment of whole area. Okay, so in this formula you substitute moment of whole area divided by total area. Moment of whole area is bh square by 6, and total area is half into base into height. Simplify. Finally you will get the expression as h by 3. Y bar is equal to h by 3 from the base, and it is 2h by 3 from the apex. Okay, so to this we are done with centroid of triangle derivation. Thank you.